Hello, grade sevens. It's Thursday morning, and we're coming up on Easter, so we don't have school on Friday to celebrate Good Friday, where we remember that Jesus died on the cross for us to pay the penalty for our sins. And coming up on Easter Sunday, then we won't have school on Monday to remember that Jesus rose from the dead and he conquered death. And so it's such an exciting thing that we get used to, but so exciting to remember what Jesus did for us and that we can live in freedom and without fear. So I hope you have a wonderful Easter. So this is the last school day of the week, and then we have a long weekend, and then we'll start up again on Tuesday. So today we are recognizing Hannah and Romeo, two of the people that did their homework yesterday among many others. So good job, Hannah and Romeo. Okay, so today we are looking at the area of triangles, and so I'm going to go through proving a little bit how we find the area of triangles. And so even if you didn't remember what the formula is, you could still figure it out based on looking at some facts. And this is how mathematicians discovered what the area of triangles were before they knew what the formula was, before they came up with the formula. And it's based on facts. So they didn't just come up with a random idea and say this is the formula. It's based on what it really is. So we'll be mathematicians today and figure this out. Okay, so on the left here it says area of triangle. So we have this rectangle and we have this pink triangle here, and this is a right angled triangle because this has 190-degree angle here in the corner. So the area of the triangle, it's equal to the area of a rectangle divided by 2. Do you see how this right angle triangle, if you flipped it, it's exactly, or flipped it and pivoted. I'm not great at dimensions, but this is taking up half of the rectangle, right? So let's find out what is the area of the rectangle and divide it by 2, and we'll know the area of this triangle. So area of a rectangle is length times width, so 4 times 2, which is 8. And we can see that there's 2, 4, 6, 8 blocks in there, so the area is 8 blocks. And so the area of the triangle would be half of that, which is 4. And if you look at this, you can kind of see that, well, let's see, that would be almost 1, 2, 3, 4. It takes up 4 blocks, okay? So 8 divided by 2, 4. Okay, now let's look at if we had a triangle that's not a right triangle, how could we find the area? So let's look at this one. So 1, 2, 3, 4, 5. Okay, then we have triangle. Okay, so this is not a right angle triangle, but what we could do is turn it into 2 right angle triangles by drawing a line right here. See how we have 1 right angle triangle here and 1 on the other side? So if we can picture this as, we can do the same trick that we did before. So we have 1 right angle triangle within a rectangle and another right angle triangle within a rectangle. So we can find out the area of this rectangle and divide it by 2 for this part of the triangle. Find the area of this rectangle and divide it by 2 to find the area of this triangle and add them together. So let's look at the length and the width. So this is 2 by 2. So this triangle, let's call it 1, is equal to 4 divided by 2, so 2. This one, 1, 2, 3 by 1, 2 for the rectangle. And then, so 3 times 2 times 2 divided by 2, which will make it 3. So triangle 2 is equal to 3, and then we'll add those together, which equals 5. Let's see if that makes sense. So the whole rectangle is 10, and it's taking up half, so it's 5. So that makes sense. So the area of this whole triangle is 5. Okay, We'll erase this one and we'll look at how to find the area of an obtuse triangle. One, two, three, four, five, six, seven. 1, 2, 3, 4, 5. Okay, let's pretend this is exactly even. Okay, and then we're going to draw our triangle, which is going to start here, cut all the way through. Oops. Let's try to make that look straight up to the corner. And then that comes down to here, so go like that. Okay, so this is a rough sketch, but let's go with it. All right, so how can we find the area of this triangle? So it's not a right angle triangle, it's obtuse, which means it has one angle which is more than a 90-degree angle. Okay, so what could we do? We can't make two right angle triangles. Well, what we can see is that this is running halfway through this rectangle. So if this triangle went all the way down to here, we would know it was half the area of this rectangle. So, but it's not quite that big. So what could we do? So, well, let's label these corners first of all. D, and then this one's E. So what we could do, first of all, is, well, let's find out what it would be if it did go all the way to D. So what is half of this whole thing? So first we have to find out what is the area of the whole rectangle. So let's count. 1, 2, 3, 4, 5, 6, 7. So this is 7 by 1, 2, 3, 4. 7 by 4. So the rectangle is 7 times 4, which is 28. And so ACD is half of that, which is 14. Okay, so let's just remember that, keep that in mind. So we can know that. We can also find out what is ECD. How can we find that? Well, we know how to find a right angle triangle, right? So if we have a right angle triangle, we know that's half of the rectangle that it would make if you flipped it. So this is half of this whole area here. So 2 by 1, 2, 3, 4, 8. So that means ECD is 4 because it's 2 times 4 for the rectangle and it's half of that, so it's 4. So now we know that this triangle to here would be 14 and this part here is 4. So if we know what all that equals and we know what this equals, we could subtract those two to find out the triangle that we're really interested in. So we could say 14 minus 4, which equals 10. Okay? So often in math, if you take all the things that you know and you write them all down and you use those things, you can find out something that you don't know. So we often get really fixated on, well, I don't know this, I don't know this, there's no way to find that out. But if you think, well, I know the area of this rectangle, I know the area of this triangle if it went to there, I know the area of this triangle, so we know this, we know that, we know that. We can use all of those things to find out the missing piece, which is triangle ACE. And we found out that it's this minus this, which is 10. So that question, that corresponds with number 4 in your book where you're doing something similar. I'm not sure if you're doing those exact numbers on that one, but you're doing that same type of thing where you find out the rectangle, you find out a triangle, find out this part that's missing, and then you find out this triangle. So it's a little tricky, but watch that again if you need to, and you can try it in your book. So for homework, from pages 172 to 174, Romeo would be saying, oh no, not 3 pages, no, please, not 3 pages. Well, we're not going to do all 3 pages. We're just doing 3 questions, Romeo, so it's not so bad. Okay, so number 1, number 5, and number 6. So I'll write that in the email and in the description box below. And happy Easter!